students, let us learn about the physical properties of amines. As we know that nitrogen is among the most electronegative elements of the periodic table. The polar nature of NH bond due to the electronegativity difference of these two atoms result in the formation of hydrogen bonding with the other amine molecules or other hydrogen bonding systems like water. The applications of this are that high melting and boiling points compared to the analogous alkanes and high solubility in the aqueous media. Now these are two molecules of aniline. You can see the charge separation due to electronegativity difference. Nitrogen containing a partial negative charge, hydrogen carrying a partial positive charge. Now students, according to the definition of hydrogen bonding, the lone pair of the most electronegative element, it attracts the highly electron deficient hydrogen of the other molecule. Now in this way a hydrogen bond is formed between these two molecules, intermolecular hydrogen bonding between two molecules. This is the reason of the increase in high melting points and boiling points as compared to the analogous alkanes. Greater and stronger the intermolecular forces of attraction, then melting and boiling points are going to be higher. Now students, due to this hydrogen bonding, it is also highly soluble in the aqueous media because it can also make hydrogen bonds with water. Students, let us look at the structural features of amine. You know that amine, this nitrogen atom of the amine, it is sp3 hybridized and it is having nearly tetrahedral structure, a little distorted tetrahedral structure because of the presence of this lone pair, which is going to distort the actual tetrahedral geometry. It forms 3 sigma bonds with its sp3 hybridized orbitals, while the fourth is a non-bonding sp3 hybridized orbital. It is carrying a pair of electron. Now this non-bonding electron pair is extremely important because it is responsible for the basic and the nucleophilic properties of amines. Means it can abstract a proton as well as by donating its lone pair to any electron deficient species. An amine with 3 different groups attached to it is optically active. Remember students that we have studied that when a carbon atom is attached to 4 different groups, then it is optically active. Now in case of amines, we say that if it is attached to 3 different groups, then that amine is going to be optically active. Now students, you can see that in this amine there is an alkyl group and 2 hydrogen atoms. So it is not optically active because it is not attached with 3 different groups. But in the next example, you can see this is R1, R2, R3. It may be methyl, ethyl and propyl and whatever. Now students, these are 3 different groups. That is why this compound is going to be optically active. Let us look at the basicity of amines. Amines act as bases towards acids, means they can easily accept protons and it can donate a pair of electrons. It can act as nucleophiles towards electrophiles. They are more basic than alcohols and ethers, and they are also more nucleophilic. For example, ether does not react, whereas at the same temperature amines give addition product with methyl iodide. Look at the chemical reactions. This is an ether, ROR. When it is going to react with methyl iodide, the reaction is not going to take place because this ether is a very weak nucleophile. It is not going to donate this electron pair to carry out the chemical reaction. Now students, whereas amines can easily donate its lone pair and make a bond with this CH3 and breaking this bond as I negative. Now since nitrogen is making a bond with its lone pair, the 4th bond is going to form. That is why nitrogen will carry a positive charge, just like ammonium ion. And that positive charge is going to attract this negatively charged iodine, making a complex salt. So you can see the basic character and nucleophilic character of amines. As we have discussed that amines are basic and nucleophilic, because of the lone pair on the nitrogen atom. This basicity depends upon the relative availability of the electron pair which is present on the nitrogen atom and stability of the ammonium ion that is going to be produced after acceptance of a proton. Now students, you can see I am having ammonia over here, NH3. It can donate its lone pair and accept this proton as well, means acting as a base as well as a nucleophile, giving you ammonium ion. Now students, if I am having methylamine, again it is going to donate its lone pair and giving you methyl ammonium ion. Now students, this is a reversible reaction. You can see in both of these examples, it is acting as a nucleophile by donating its lone pair and accepting a proton, so acting as a base. Students, let us compare the basic strengths. You know that the strength of a base is expressed in terms of pKb values. For example, you can see this is ammonia and this is methylamine. pKb is equal to negative log of Kb. What is Kb? Dissociation constant of a base. Now students, the pKb value of ammonia is 4.76. whereas that of methylamine is 3.38. And you have studied in first year that smaller the value of pKb, greater is the basic strength. So, this can be concluded that methylamine is a stronger base as compared to ammonia. Now students, what is the reason? You already know that methyl groups are electron donating groups. Now this nitrogen is a nucleophile. It can donate its lone pair. But this methyl group being electron donating, giving an electron donating effect, assists the donation of this lone pair. So the nucleophilic character is going to increase, means the basic character will increase. That is why it is 3.38. Whereas in amine, no such methyl groups are present to increase the electron donating effect of this nitrogen. That is why the value is 4.76. And ammonia is a weaker base as compared to methylamine. The second reason for the increased basic character is the methyl ammonium ion that is going to be produced after acceptance of a proton is stabilized due to the electron donating inductive effect of the methyl group. On the other hand, when NH4 positive ion is present, it is not stabilized by the hydrogen atoms. Both these factors favor methylamine to be a stronger base than ammonia. Now students, this positive charge is stabilized due to the electron donating effect of this methyl group, whereas the positive charge of this ammonium ion is not stabilized because there is no alkyl groups to stabilize it. That is why methylamine is going to be a stronger base as compared to ammonia. Now students, higher members show deviation to this argument. It is because the stabilization of this positive ion also depends upon the extent of solvation. Now you know what is solvation. When a cation or an anion is surrounded by the solvent molecules. Or the ion can also be stabilized by hydrogen bonding, and resonance stabilization may also affect the stabilization of this positive charge when it is present in such a molecule. Larger the size of alkyl ammonium ion, it is going to become more non-polar and hence it is going to be less solvated. Now students, if I am going to have greater bulkier alkyl groups, it is going to make this non-polar because of the presence of hydrocarbon chains. And further, this positive charge is going to be restricted between these alkyl groups. The crowding of the alkyl groups is going to hide this positive charge, and that is why it is going to get less solvated. The molecules of the solvent cannot approach it. That is why it will be less solvated. Moreover, the availability of non-bonding electron pair of the electrons is also affected by the steric factors in addition to these aspects. Now students, we have discussed that when methyl is present along with nitrogen, it was increasing its electron donating effect. But it might happen that if we are having bulkier groups, due to crowding, that nitrogen might not be able to donate its lone pair. That is why it is going to affect